Welcome to Dr. B.R. Ambedkar Open University MBA first year, second semester students, quantitative techniques subject. In that Black 5 hypothesis testing we are doing now. Under this unit 17 tests of hypothesis, we will divide this topic into two parts. One, parametric tests, second part, non-parametric tests. Now coming to the procedures which enable us to decide whether to accept or reject a hypothesis, that is null hypothesis, and to determine whether observed sample results differ significantly from expected results are called tests of hypothesis. They are also known as the tests of significance, rules of decision, or decision procedures. The tests may be broadly divided into tests for attributes, tests for variables. An attribute is a qualitative phenomenon which can be observed and counted but cannot be measured. For example, male, female, taste, beauty, etc. are the examples of qualitative or attribute phenomenon. Whereas a variable is a quantitative phenomena which can be measured, like height, weight, income, etc. So the tests for attributes may be Z test for proportions, chi-square test for independence. Tests for variables may be Z test, T test, F test, and chi-square test for goodness of fit. So problems in these tests are of two types: estimation type and hypothesis testing type. Now, the statistical estimation and hypothesis testing, first we will take up sampling of attributes. Now, sampling of attributes, again the problems will be of two types: estimation type and testing, that is hypothesis testing type. And in case of sampling of variables also, you will have large samples and small samples, and again here also estimation type of problems and hypothesis testing type of problems. So this is, now in this lesson we will see about the parametric tests, and in one more lesson we will do on non-parametric tests. Now coming to the sampling of attributes, as we said earlier, an attribute is a characteristic or quality which cannot be measured, but whose presence or absence can be identified and counted. For example, number of people, number of males, number of females, etc. The study of attributes is of great importance in business situations. Whether it is a large or small sample, use Z test only for attributes. Various attribute examples are presence or absence of a phenomena, effective or not effective, defective or not defective, yes or no, accept or reject, preferred, not preferred, success or failure, etc. These are the examples of attributes. Now, coming to estimating and testing of attributes. Now, first this attributes type of problems can be looked in under two heads. One, estimation type of problems, two, testing type of problems. Now, estimation may again we have point estimation and interval estimation. In point estimation, only whatever the sample proportion, if it is a point estimation, in point estimation we take only the sample proportion, and sample proportion is the point estimate. Whereas interval estimate, in interval estimate we take the sample proportion, then take the z value at 5% level or 1% level, then calculate the standard error. So, in interval estimation, sample proportion plus or minus critical value of z and multiplied by standard error, then proportion plus this, proportion minus this will give us the interval, and that will be the interval estimate. In case of hypothesis testing, small or large, whatever the sample size, in case of attributes, use only z test. Now, here we have three types of problems. One, number of successes, we take actual numbers. Two, proportion of successes, instead of taking actual numbers we take the proportions like 50%, 50%, 60%, etc. Then second is comparing the significance of the difference between two sample proportions. So, these are the types of problems we come across. Now, proportion of success, first type of problems. Here again the point estimation is, so in proportion of successes, actual numbers, we take actual number. For example, when you are contesting in elections, how many votes you expect? You expect 1 lakh votes or 2 lakh votes. Then what you are expecting actually out of 2 lakh voters, how many votes you are expecting? For example, I am expecting 1 lakh out of 1,50,000. So, that means you talk in terms of actual numbers. This is what we call actual number of successes. Here point estimation is whatever the actual number. For example, you are expecting one sample data you have taken is, so the number of successes, the point estimation is sample number, whatever the number. Here you said 1 lakh is you are expecting the number. Then interval estimate, if you want to do, what is the confidence with which you want to estimate? With a 95% confidence, I can say that I will get so much of votes, for example. Then whatever the sample actual number plus or minus, at 95% level the z value is 1.96, and apply the standard error formula. Here the standard error formula is NPQ. There is n number of sample, P is actual number, Q is minus that, NPQ. So, under root. So, calculate this, multiply with 1.96, then sample number plus this, sample number minus this will give you the range, and that is the actual number of successes. Now, depending on whether the difference between the two is statistically significant or not, decide that if the z value is less than the table value 1.96, accept the null hypothesis, otherwise reject the null hypothesis. proportion of success. In this case, point estimation is sample proportion P. Interval estimate is sample proportion plus or minus Z value, whatever that level, into standard error. The standard error formula in this case is PQ by N under root, that is the sampling error. So, Z statistic will be sample proportion minus hypothesized proportion or population proportion by standard error. Continue the problem. In a sample of 2000, so now we will take an example to demonstrate how the proportion of successes will be estimated and tested. In a sample of 2000 births from a birth register, 53% are males. With this data, can it be said that the sex ratio of births is equal? Now, continuing the problem is whether the birth rate is equal or not. The hypothesis is the sample proportion is 0.53 or 53%, and null hypothesis is P is equal to pi, that is sample proportion is equal to, what is the sample proportion? 53. That is estimated is, say generally we expect the birth rates are equal, that means 50-50. So, P is 50, pi is 50, that is the expected one, but the actual one is here 53% or 0.53. So, level of significance we want to test at 5% level of significance. So, at 5% level of significance, the table value is 1.96. So, in this case, point estimation is P, that is 53%. Interval estimation is P plus or minus Z value, critical value of Z into standard error. Hypothesis testing, okay, this is all repeated. Now, here the level of significance, as we said, it is 95% level of significance. The Z value at 95% confidence is 1.96. The test statistic for proportion of successes is Z is equal to P minus pi by standard error. The standard error formula is PQ by N, whereas P is the proportion, P minus 1 is Q, and by N is sample number under root. So, calculate the standard error. So, here the calculations P, that is sample proportion is 0.53, and Q 1 minus P is 1 minus 0.53 is 4.47, N is 2000, and standard error PQ by N is 0.53 into 0.47 by 2000, and we calculate the Z value is 0.012. Now, put it into the test. Z is P minus pi by standard error, that is 0.53 minus 0.5 is pi, that is expected number, and the standard error is 0.012, and if you calculate, you get 2.68 the calculated value. The decision rule is accept the null hypothesis if the calculated Z value is less than the expected value, otherwise reject the null hypothesis. Now, the decision is, since the calculated Z value is 2.68, which is more than expected value 1.96. Therefore, we reject the null hypothesis and accept the alternative hypothesis. Therefore, the conclusion is sex ratio is not equal in this case. Now, just now we have seen significance of the difference between the parametric proportion and sample proportion. Now, if two different samples are taken, sample 1 and sample 2, and we calculate, we get P1, that is the proportion 1, the sample proportion 1 and sample proportion 2, whether there is significant difference between these two proportions. And when two samples are drawn from two different populations, we may test whether the difference between the two proportions is significant. Now, the steps involved here are find P1 and P2, that is sample 1, sample proportion 1 and sample proportion 2, and calculate the combined proportion with this formula. The formula for combined proportion is P is equal to N1 into P1 plus N2 into P2 divided by N1 plus N2. And whereas the Q is 1 minus the combined P. And the standard error formula is under root of P Q into 1 by N1 plus 1 by N2, you get the standard error. Now, convert these calculations into Z score. Z is P1, that is sample proportion 1 minus sample proportion 2 divided by the combined standard error, and calculate the value and compare with the decision rule, and compare the calculated value with the expected value and conclude. This is the procedure involved in sampling of attributes. Now we will move into sampling of variables. Variable, any item which is measurable and not a quality or attribute, is a variable. A sample size of 30 or more than 30 is considered as a large sample. A sample with a size of less than 30 is called a small sample. Assumptions made for large samples do not hold good for small samples. That is why we have different formulae for small samples compared to large samples. Hence, tests for small samples and large samples, they differ for large and small samples. For large samples, we use Z test. Now, here also we have two types of problems: estimation type of problems and testing type of problems. And we said that large sample is one which is whose n, that is sample size is 30 or more than 30, is called a large sample, and we use only Z test for this. And estimation type of problems, again here we have point estimation and interval estimation. In point estimation, sample mean is the population mean, that is we assert whatever the sample mean, that is the population mean. In case of interval estimate, we calculate sample mean plus or minus Z, that is the critical value of Z at stated level of significance into standard error. And the test statistic is Z is equal to sample mean minus population mean or hypothesized mean by standard error, and the standard error formula is standard deviation divided by square root of sample size. For now, coming to estimation from large samples, the procedure of estimation is the same as said earlier. We will demonstrate it with an example. For example, a random sample of 400 items is found to have a mean of 82 and a standard deviation of 18. Find 95% confidence limits for the population mean from which the sample is drawn. The solution is n is 400, that is sample size is 400, mean of sample is 82, standard deviation of the sample is 18. Now the standard error is 18 by square root of n, that is 400, 18 by square root of 400 is 20. So the calculated value of standard error is 0.9. So the point estimation is 82 is the point estimate, whereas the interval estimate is a sample mean plus or minus 1.96 into standard error, that is 82 plus or minus 1.96 into 0.9, and we get 82 plus or minus 1.76. So after these additions and deductions, lower limit is 80.23 and upper limit is 83.76. Now the conclusion: with 95% confidence, the population mean lies between 80.23 and 83.76. Testing of large sample mean of a population. The large sample mean of a population is, here also the procedure is same: state the problem, state the level of significance, and set up the hypothesis, then identify the decision rule, identify the test statistic, and finally do the calculations and compare and conclude. Similarly, testing of significance of the difference between two sample means, that is sample 1, sample 2, and sample 1 calculate the mean, sample 2 calculate the mean. Then very frequently we compare two samples, such as two products, two drugs, two machines. The procedure is demonstrated through a numerical example. Take an example: the road transport company is interested in buying tires. The tires produced by company X and company Y are tested. The following results were obtained: which company's tires you want to buy and why. Use 5% level of significance. The problem is, company X number of tires tested are 50, the average life of the tires of X is 22,400 kilometers, and the standard deviation of X tires is 1100 kilometers, whereas company Y's number of tires tested also 50, average life of company Y tires is 21,800 and the standard deviation is 1000. Now the problem is, we want to test whether to purchase company X or company Y, whether the difference between 22,400 average life of X and 21,800 kilometers of Y, whether the difference between the two is statistically significant or not. That is what we wanted to test. The hypothesis is, we said that there is no difference between these two. The alternative hypothesis is, there is significant difference between the two. For example, the null hypothesis, 22,400 is equal to 21,800, that is both the tires. and the alternative hypothesis says 22,400 is not equal to 21,800. There is significant difference between the two, or like one tail test you can put it 22,400 is more than 21,800. Now here the level of significance is 5% we have taken. Test statistic is, since the data relates to the difference between large samples, Z test is used. Z is sample 1 x bar 1 minus x bar 2 by standard error. Decision rule is accept the null hypothesis if the calculated Z value is less than the table value 1.96, otherwise reject the null hypothesis. Now the calculations are, standard error is, it's the difference between two samples, two large samples. So standard deviation 1 by n1 plus standard deviation 2 by n2, both variances, and under root, and the calculated standard error is 210.24. And the putting into the test, Z is equal to x1, that is the x bar 1 minus x bar 2 by standard error, that is 22,400 minus 21,800 divided by 210.24 is 600 by 210.24 is equal to 2.85 is the calculated value. So the decision is, the table value at 5% level of significance is 1.96 for two-tail test. If you take it as a one-tail test, it is, the table value is 1.645. Whatever it is, the calculated value of Z is 2.85 is more than the table value at 95% or 98%, 99% of confidence. Therefore, the null hypothesis is rejected. Now, in this lesson, we have taken up the parametric tests. A parametric tests are one where we assume there is a hypothesize or assume some parameter, then we assume a normal distribution also, and such tests are Z test, T test and F test. And in this parameter test we have two types of problems, estimation type of problems and hypothesis testing type of problems. And again we have variables and attributes, attribute type of problems and variable types of problems, and the standard error formula will differ from case to case. Now in all these cases we have seen with example estimation type and also the hypothesis testing type of problems, and we have also explained the procedure, and these are the non-parametric parametric tests. Sorry, in the next lesson we will see about the non-parametric tests. Thank you very much.